Hello! So the last thing that we're going to do in this chapter is we are going to look at using simulations to calculate out probabilities. Now this is something we'll definitely be doing in 690 when you take it. And so what we're going to do is we're going to assume a normal distribution, and we're going to use a function to throw in random numbers. So basically what we're going to do is we're randomly going to run a check and test. Had to pause it there because my dog started barking at somebody outside. But we're going to do this random check and test where we're going to be able to come up with multiple different situations. In our case, we're going to test 1,000 situations, and then we're going to group up the chances that's going to happen. So anyway, let's look at the problem. A manufacturer of a particular bicycle model has the following costs associated with managing of the inventory. In particular, the company currently maintains an inventory of 1,000 units at the beginning of the year. If X units are demanded each year and X is less than 1,000, the excess supply, 1,000 minus X, must be stored until next year at the cost of 50 a unit. If X is greater than 1,000 units, the excess demand, X minus 1,000, must be produced separately, and it costs an extra $80 per unit. So we're going to assume that the annual demand for this is distributed normally with a mean of 1,000 and a standard deviation of 75. So we're going to be using a normal distribution here. So we're going to answer two questions. We are going to find the expected and annual cost associated with managing potential shortages and surpluses. And this is where we're going to use simulation to get an approximate answer. Could you get an exact answer using probability arguments? Yes, but it's really beyond the level of this book. But more importantly, it's beyond the level of what we need you to do in this class. And then we're going to use a data table, and we're going to evaluate the expected annual cost for varying initial inventory levels. And we're going to figure out what's the best level based on our simulation. Okay, so we're going to go here, and we've already got it set up. We've got a part B. That's our part 2. We're going to be using our data table. And part A is we're going to calculate out our costs based on what's going on in our simulation. So we're going to do 1,000 different variables. So the first thing that we're going to do is we're going to do the demand variable. And this is the one that'll probably be, coding-wise, there's a lot going to go on. So let's just dive into it. So the first thing we're going to do is we're going to try to figure out the demand, so the probability. So we're going to be using that normal inverse function because we don't actually want the percentage chance, we want an actual number. So if we go to our normal distributed inverse, so returns the inverse of our thing. We don't want the dot S because we want not a standardized distribution, but just a normal distribution. Now the thing is probability. We're going to be running a simulation, so we need a bunch of random numbers. So how do we get that? We're going to use the RND function. So rand, it's going to give me a random number between 0 and 1, and it's going to be evenly distributed. So there's not going to be, it's a uniform function. So we're going to run it 1,000 times, and we're going to have the exact same chance that 0.1 and 0.11 and 0.111 show up. So we'll use rand. Now rand is one of those functions that there is nothing that you put in, just open and close the parentheses, and it's going to run. So that gives us between 0 and 1. What do our probabilities end up? Between 0 and 1. So that's great. That's going to give us it's going to simulate demand for us. So now we've got our mean. So what is our mean? Our mean is going to be 1,000 units. We're definitely going to lock that in. And then our standard deviation, the standard deviation is going to be 75 units. We're going to lock that in. And so that's it, because it's going to give us a number. So if we execute and run this, we get 1,024.69. That's sort of what we wanted because we did want a demand, but you can't have 0.69 part of a bike. A bike is going to be a whole number. So what we're going to do is we're going to add a function in here called round, and round is going to round a number. So that'll be this entire thing that we have here to a number of digits. We want it rounded to 0 digits because we want no decimal places. And so now we've got 1096. Probably all sitting there going, wait a second, it was 1026 before. What happened? Well, that's part of the random function that every single time that we put another calculation, it randomly spits out a new number. And this is why you're going to be doing 1,000 of them, because we're really shooting for as many different tests that we can get so we can come up with a percentage probability that all this stuff's going to happen. So it's a simulation, it's going to change. Okay, so now we're going to look at our storage cost. Well, what is our storage cost going to be? Well, we only have storage costs if we don't sell enough bikes. So we're going to be running an if statement. So if our test is going to be, if our demand is greater than our initial inventory, so that means that we have sold more bikes than we initially stocked, and we'll hit F4 to lock that in. Well, that means if that happens, our storage cost is going to be 0. Otherwise, we've got to pay to store the bikes, and storage cost is going to be $50 a bike, F4 to lock that in, and then we're going to multiply that by the number of bikes that we have, which will be our initial inventory, once again F4 to lock that in, minus our demand. And there we go. Now this is where range names actually makes things a lot easier. So let's go back and put those in. So I'm going to highlight all these guys here because these are the ones I'm going to use. I'm going to go to data. I always screw that up. As I actually go to formula, create from selection, left column. So now I'm going to go back and I'm just going to change this a little bit. So instead of using B8, we're going to put in mean. Instead of using B9, I'm going to put in standard deviation. And then so if we go here, I'm not naming this row because I can't really change it. But if those units are greater than the initial inventory, 0. If not, it's going to be the unit storage cost times the initial inventory minus whatever we've sold. And I like this because it's easier to kind of read through the equation. And so that's going to be my storage cost. And you notice every time I hit enter, it's recalculating. This is why we're going to do 1,000 different permutations of this. Okay, storage cost. Oh, excuse me, shortage cost. So we're going to run another if statement because one of two things can happen. So if my demand is going to be greater than 1,000, so this is the other way. So if it's going to be greater than 1,000, I've got to make more bikes. And the number of bikes that I'm going to make is going to be our shortage cost times the number of bikes that I've made that I'm going to have to make, which is going to be the demand minus 1,000. So I know that's going to be a positive number because my B13 is greater than my initial inventory. And so if it is greater than my inventory, it's going to be this unit shortage cost times how many I have. Otherwise, it'll be 0 because I will have no unit shortage cost. And so anytime that I have a storage cost, I will have no shortage cost. Anytime that I have a shortage cost, I will have no storage cost. And so we're just going to sum both of these together. And now what I need to do, so here we go, storage cost 0, shortage cost 4,800. So now what I'm going to do is I'm going to highlight all of these, and I got to drag it down 1,000 times, or I just double click here because it knows that there's numbers here, and it's just going to fill things in. Okay, so I've got this here now, so I've got 1,000 different tests. So what am I going to do? I'm going to figure out what my annual costs are. So my annual cost will be the average. Why am I doing the average? Because I have these 1,000 different permutations of what could be. 1,000 different possibilities. And so I'm taking the average of all 1,000 of those. And that's going to say, well, based on all of our, simulation, that should be the average. That's the average cost of all of them, which should give me a pretty good idea of what the cost will be. We're going to do the same thing with shortage, and that goes to 1012, so we'll do the same thing here. So we'll go average, and we're going to start in, and as we said, we looked at that went to 1012. I'm just going to type that in. And so our average storage cost is $26.33. Now, is this, that keeps changing. If we go in here and actually execute something, it rolls, it changes, and that's just going to happen because we're simulating it 1,000 times. And then I'm going to sum the two of these together. Okay, so obviously, since we've got all this random stuff going on, that means that it has to be, no matter how many times we do this, it's going to be completely different. It's going to completely change. Yes, but we're doing 1,000 of them, so we're trending, we should be kind of close. Case in point, if I go and you look at the answer in the book, I believe that it says that its total cost is somewhere on like $37.95. In fact, the one I've got here says $37.95, $39.54. So it's off by a couple hundred, but it is relatively close. Anyway, so that's the answer to our first one, the expected annual cost. That's kind of where we're at with 1,000 simulations. The more simulations we do, the more accurate it will get because the amount of errors can be kind of tampered out. So what I want to do is I want to drag this equation down to here, and then I'm going to make my one-way data table. So I'm going to highlight all the stuff that I'm going to change, plus the row that I want to put it in, and I've got my equation there. So I'm going to go to Data, What If Analysis Data Table. Remember, I'm changing things in the column, so what I want to change is my initial inventory. So I'm going to go up here to Initial Inventory. This equation, this answer through all these equations does tie back to initial inventory. If it doesn't, this won't work. So it's got to tie back in there. I'm going to hit OK, and it's going to fill in. Now, there was a conditional formatting already put in here. So if you go to Home, Conditional Formatting, and you've got different rules, we'll just manage the rule. So what we've done is we've gone in and we've applied, hey, whatever the bottom one is, highlight it green. So how we do that, we would go to Conditional Formatting, Top 10, Top Bottom Rules, go to Bottom 10 Items, and then you would just take it down to the bottom one, and that would give you the lowest. And then change it to green. So this is going to tell us that our initial average inventory should be 1025. Now the thing is, we've run 1,000 tests for that. And so if I keep recalculating the data, if I force it to recalculate, you're going to notice something. 1025 is never going to change because we've run 1,000. Oh wait, I take that back. We did have one. It's bouncing between 1025 and 1,000. I did not think it was going to change, but they're close enough together. But you can see that it's mostly 1025. Occasionally bounces to 1,000 because we've run this many simulations. If we double this to 2,000, 3,000, it'll probably be a little bit more consistent. But we're able, with the use of all of these different tests, to, with a random possibility, calculate out what the best place to be is. Okay, if there's any questions, please let me know. If not, until next time, I'll see you guys later.